Hey, welcome back to the lecture. So in this lecture, let's do one exercise. So write a program to do mathematical operations such as addition, subtraction, multiplication, and division of integers. So you have to follow these two steps. One, do all the mathematical operations in a separate functions in a file called math.c and call the functions from the main.c to test them. So basically, your project should contain two source files. One is math.c. Let's say it is written by you. And inside the math.c, you have to write functions to do the mathematical operations. And let's say there is one more source file called main.c. Let's say it is written by someone else. And main.c uses functions of math.c. So here you can use the concept of header file. So you write all the function definitions in the math.c and you write all the function prototypes in a file called math.h and then share that math.h with main.c. So the main.c will come to know what are all the functions supported by math.c by looking at its prototype. So I just created a project called math. And after that, let's add two source files. So first let's create one source file and I would call this as main.c. And let me add another source file. Let's call it as math.c. Let me finish. So this is excluded from the project. So I don't know why. Don't worry. So for you, it may not be like this. Let me just go to the properties and uncheck this. Go to the C and C++ build and uncheck this option. Apply, apply and close. So in the main.c, we are going to write all the functions for our arithmetic operations. Before writing functions, let's first create the function prototypes. So let's give the name first. So let me call it as math add. This is a function name. And after that, let me give the parenthesis here. And here, let's write the input arguments. So this function takes two arguments. So it is used to add two numbers of integer type. So int, let me call it as n1 and int n2. Let's say it returns a result back to the caller, isn't it? So the type of the return value, so let's consider it as int. And now let's terminate the function prototype. So this is the first function prototype. Let's create other functions. Let me copy and paste. So let me call it as sub, mul, and div. And for the subtraction, also I would like to use the same prototype. And after that, multiplication. So here, n1 will be multiplied to n2. So the result may exceed int range. So that's why let me use here long int. The return type I would like to use long int. The math division, so here n1 will be divided by n2 and the result may be float, isn't it? So two integer divisions can result in float, right? But in C, what happens is integer divisions result in integers. So they will not result in float, but we'll see how to convert that into float. So this is my function prototypes and let's implement. Let's implement all these functions. So that's what we call as function definition. Again, copy and paste here and just give the function body. So let's not keep this function prototypes inside math.c. So now let's create one more file called math.h. So let's create that header file. So here select default C header template and give the name math.h. So once you create the header file, you can see that this IDE is automatically adding these macros. So these are called as include guards. So you should make sure that your header file contains this include guards. So if the header file doesn't contain this include guards, then you should write this include guards manually. So here this is called as a pre-processing or preprocessor directive of the C compiler. And this can be any value. So it can be set of any characters. So it actually avoids multiple inclusion of the contents of the same header file in a project. So now we are going to keep our function prototypes between these statements. So we are going to So let's cut this code from here and let's put that in math.h. So these are also called as exposed function prototypes because the main.c can include this, and it will come to know about the function prototypes of math.c functions, right? So now let's implement the functions. So here let me just return n1 plus n2. So only one line of code. So here let me return n1 minus n2. Alright, so now let's return here n1 multiplied by n2. So to multiply, you have to use asterisk. So this is actually results in integer value, right? So because n1 is an integer and n2 is an integer, and if you multiply those two numbers, it will result in integer. Let's move on to the math division. So here, let me just want to do n1 divided by n2. And this is also integer division. So here we are dividing two integers, right? So the result will be an integer. It will not be a float value. So later we'll see how to fix this. So now our math.c is completed. So now let's go to main.c. So main.c is empty. So first let's write the main function. And after that, first let's include the math.h because we are going to use those functions, right, which are implemented in math.c. So let's include math.h. So this is how you include a user defined header file. So this is written by the user, right? So this is not given by the standard library. So that's why I have to include like this. So I have to mention the name between the double quotes. So you cannot use this. So you cannot do something like this. This is wrong, right? So all the user defined header files must be within two double quotes. And let me include standard library header file. And after that, let's use those functions. So let me printf add. Let me print the result of adding two numbers, %d, right? And here in the printf, I can directly call that function. So you can directly call this function, let's say math add, right here, math add. So you have to call this function with two numbers. Let me write the first number in hex, a 4-byte value. Let's say 0FFF1111. So this is a 4-byte value, right? And this is a positive value because the most significant bit is 0, right? That's why this is a positive value. And after that, let me add another number in hex. So let me keep the same number. So here, this is a function call. Note that you need not to terminate this function call with a semicolon here. It is not required because this is a complete C statement and a C statement is terminated by a semicolon. And the math add actually returns the result, right? So that result will be printed with a format specifier %d. So now let's run. Let's see what happens. Here it is. So this is the result. So now let me verify with the calculator. So I have a calculator here. First, let me write 0FFF1111, which happens to be this number in decimal, and this happens to be this number in binary. So plus FFF1111. So which happens to be 536748578. So this is a hex format. So if you want to print that in hex format, use X here. So that seems to be correct, right? After that, let's call multiplication on the same number. Let's see what happens. So the multiplication of these two numbers will result in a bigger number, right? So it will be of size 8 bytes maybe. Let's first try in calculator. So let's see what happens. So let me copy this number and let's say whether it takes or not. It takes, no problem. Multiplied by the same number, which results in a very big number, right? So this is a decimal equivalent. This is a hex equivalent. And you can see that. So this is actually of 8 bytes, right? Long int type. So now let's see whether our code prints the correct answer or not. So this must be the correct answer. Let's see what happens here. So by the way, we are printing 64-bit value, right? That is 8 bytes value because this actually returns, oh, sorry for that. So I have to use multiplication here. So this function actually returns long int, right? So that's why I have to use the format specifier long int. So that is I64x. And now let's see how it goes. Let me run. So now you can see that the multiplication result is wrong, right? So it just printed the last 4 bytes. And the upper 4 bytes are actually discarded. So that means there is an information loss, right? The reason for that is if you just take a look into this function, so here we do integer multiplication, right? So integer multiplied with integer results in integer. So now in order to solve this problem, so what you have to do is you have to consider one among these number as long int. That means you have to typecast one of the variable. About typecasting we'll see later, but let's use the typecasting in order to solve this issue here. So let's change the type of this number to long int. So that we can do by casting. So in order to do casting, in front of the variable name, open the parenthesis and mention the data type name to which you want to cast. So let's do that. So here I am casting. This is a casting to this variable. Now I'm changing the type of this variable to long int. So now a long int variable multiplied with int results in long int. So now it should be good, and more on typecasting we'll explore in the later lectures. So there are two types of casting actually, or typecasting. One is explicit casting and another one is implicit casting. And this is what we call as explicit casting. That is, you are manually doing that. So after that, now here also we have to cast because integer divided by integer results in integer. So here also you have to consider this number as float. So one of the number as float. Let's try once again. So now let me just print up. Let's also test the division. And the format specifier is %f for float. And let's divide 100 by 8. So now let's run the program. And here you can see that we actually get the correct answer, right? Now the answer is correct. That's about this program, and I would suggest you to reproduce this application at your desk in the next lecture. So I'll be covering typecasting.